Hey everyone, this is Remy, and this video is going to cover the note outlines for Math 124, Chapter 4, Section 6, which is polynomial inequalities and rational inequalities. So in an earlier section, in section 1.6, we solved linear inequalities. And then in this section, we're going to discuss how to solve nonlinear inequalities, namely two types: polynomial inequalities and rational inequalities. So the linear inequalities, there are a few things to keep in mind, but I think the number one thing there was that if you ever multiplied or divided by a negative number, you had to reverse the inequality symbol. And then there's a lot more to consider, and you have to be paying close attention to a lot of details in these solving polynomial inequalities and rational inequalities. But they both generally follow these guidelines. So this is just a summary of the steps. And then when we actually go and do some examples, it'll be a little bit more detailed, but this is just kind of a summary. So solving nonlinear inequalities, so this is for polynomial or rational. Still want to follow these same basic steps. So first, move all the terms to one side. So you're going to have 0 on one side and everything else on the other. Secondly, if there's any factoring that you can do that, if applicable. Or if there are fractions involved, you need to combine the fractions, right? So adding or subtracting them, so that's usually you need to find an LCD and combine them somehow. Once you've done that factoring or combining fractions, then find what are called the critical values. And the critical values, there's two different types that you need to find. One of them is when the entire expression equals 0. Find what those values would be. Or when any original denominators equal 0, because you know you can't have a denominator equaling 0. And then on step 4, on a line graph, we're going to test a point that's in each interval. And by testing, we're caring about, is it going to come out positive or negative? And then step 5, write your solution based on the results found. So let's just do an example, or actually this whole section is just doing a lot of examples. Okay, to get the hang of this. So first we're going to start with polynomial inequalities. Solve the following polynomial inequalities. So first step, we need to move everything to one side. So I think it's a better idea to always move everything to the left side. So we're going to subtract the 5x, and then add the 6, and then that will leave us with this. Now step 2 says factor if we can, or combine fractions. Well, we don't have any fractions, but we can factor this. We need two numbers that multiply to 6 and add to -5. Okay, so those will be -2 and -3. So now we're on step 3, find the critical values. So when does the expression itself equal 0? Well, so critical values, that would be, x would be 2 or 3. If you set each of these factors equal to 0, you get 2 or 3, because that would make the whole expression 0. And then, or when any original denominators equal 0, but we didn't have any denominators. So these are our only critical values. So these two, we're going to plot on a number line. Also, we need to decide whether we're going to put open or closed circles. Well, according to this symbol right here, it says equal to. It could be less than or equal to 0. So it can be 0, so we can include these. So closed circles for both of these. And I'm going to always draw my little symbols for them down here because they won't always be closed and they won't always just be open. Sometimes there'll be a mix as well. So I'm just going to draw my symbols to tell me which ones they are. So here, they're closed. And then step 4, it says on this line graph, we need to test a point in each interval. So by putting these critical values in, that created 3 intervals. So I'm going to plug in a number from each interval, and you plug in the easiest that you can. So over here, the easiest number to plug in is 0. So you plug it into this equation, or to this last form. 0 minus 2 is, and also we're only caring about, is it going to come out positive or negative? So you don't even need to find the actual value, you just need to be concerned with, is this going to come out positive or is it going to come out negative? So if I plug in 0 here, I'm going to get a negative number. If I plug in 0 here, I'm going to get another negative number. So we'll have negative times negative is positive. And then I'm going to skip this region at the moment because there's not an easy number to plug in. Over here, I will plug in 5. If I plug in 5 here, I get a positive number. 5 minus 2 is positive. Here, 5 minus 3 is also positive. Positive times positive is positive. And then in the middle, I guess the easiest number to plug in is 2.5, right in between the two numbers. If I plug in 2.5, subtract 2, that's still going to be positive. Here, if I do 2.5 and subtract 3, it'll become negative. So plus times a negative is negative. Alright, and then the next thing we have to think about is, do we want the positive regions or do we want the negative region? So to find that, you have to take note of what's going on here. This says that this expression can be less than or equal to 0. Well, if it's less than 0, that means we want the negatives. Therefore, this part here is the one that we want. And I'll just write that in interval notation. And the 2 is included because we said it was closed circle. So we're going to start at 2 and go up to 3, and we're including 3 as well. So that would be our solution. Anything from 2 up to 3, if we plug it into this original, it will make the inequality a true statement. Okay, so let's do another one. Part B. Step 1 is already done. All the terms are already moved to one side. Step 2 is already done. It is completely factored, so that's nice. So steps 1 and 2 are already done. Alright, step 3. Find the critical values. So when does this whole expression equal 0? Well, if we want the whole expression equal to 0, then we would just set each factor equal to 0, and we'd get, don't forget this one out in front, this one would give us the number 0. This one here gives us the number 1. This one here gives us the number 4. So these are our critical values, 0, 1, and 4. We're going to plot these, 0, 1, 4. We also need to decide, are we going to have open or closed circles? Well, this time, look at the symbol. It says just less than. So we do not want to include these numbers because they make it equal to 0. We don't want that. So this is open, open, open on all 3 of them. Now we're going to test points. If we plug in, let's just plug in, I don't know, negative 10 over here. So if I plug in negative 10, this one is negative. And then this part, x minus 1, negative 10 minus 1, that's still negative, but then we're going to square it, so it'll become positive. So we have negative times a positive so far. And then down here, if we plug in a negative 10, the whole thing will become negative. So negative times a positive times a negative is eventually going to give us a positive number. So notice I'm not even figuring out what the number is going to be. I'm purely caring about whether it's going to be positive or negative. Now, I'm going to skip this one because we're going to have to plug in a half. But, well, let's just do it then. So this one, there's not really a nice number to plug in, so I'll just plug in a half, which is halfway between these two numbers. So if I plug in a half here, well, a half is positive, so we got positive. If I plug in a half here, subtract 1, whatever number that is, we're going to square it. So it's going to become positive. So we have positive times positive. If I plug in a half here and then subtract 4, that definitely becomes negative. So we have a positive times a negative is a negative. In this region, let's plug in the number 2. So we have positive here. 2 minus 1 is 1, squared is positive, so positive times positive. And then 2 minus 4 is going to be negative. So positive, positive, negative, so we're going to get a negative. And then out here, let's just plug in the number 10, I guess. I'll get a positive number here, definitely positive here, squared, positive, and then 10 minus 4 is still positive, so we're going to get positive. Okay, and now we need to decide which of these regions do we actually want to keep. And so again, I'm going to go back here. This says that we want our expression to be less than 0. So again, we want the negatives. So this region's good and this region's good. So just write that in interval notation. We want to start at 0, but we do not want to include 0 because it has the open circle, up to 1. And then close it because we don't want to include 1. So we have to put union, start back up at 1, go up to 4. And those are the only two regions that we want, so that would be our solution. Okay. All right, let's do another one on the next page. Part C. So step 1 is move everything to one side. This already, of course, everything is on one side. However, I mentioned earlier that it does turn out, it's just going to come out easier for you if you put everything on the left side. So I'm just going to like flip this whole thing around. I'm going to put x cubed minus x is greater than 0. That's the same thing. Because if you have, say for instance, 3 is less than 5, that's the same thing as saying 5 is bigger than 3. So just flipping everything around. And now, so that's step 1 basically, everything's on one side. Step 2 is factor if possible. Can we factor this? Well, yeah, first thing we always look for is GCF. These two both have an x in common. And then we'd be left with x squared minus 1 is greater than 0. Can we keep factoring? Well, yeah, because this is difference of squares. So we have x times x minus 1 times x plus 1 is greater than 0. And now we're done factoring. So, next step is find the critical values. CV, okay, when does this expression equal 0? Well, when x equals 0 for this factor, 1 for this factor, and negative 1 for that factor. And then, are we going to have open or closed circles? Well, strictly greater than, so we're going to have open, open, open. So let's put this on a number line. And make sure you do it in the right order. Negative 1 is the smallest, and then 0, and then 1. And we have open, open, open. We're going to test numbers. So for this region over here, I'll just plug in negative 10. So we'll have a negative here, and then a negative here, and a negative here. So negative times negative times negative overall will be negative. And then here, we're going to have to plug in an annoying number, I guess, which is -1/2. So plug in -1/2 here, it's negative. Plug it in here, it'll be negative. So negative times negative so far, which is positive, times -1/2 plus 1, that's going to come out positive. So we have negative, negative, positive, so overall it's going to be plus. Now let's plug in 1/2 for this part. Get 1/2 times 1/2 minus 1 is negative, so positive times negative, and then if we plug in 1/2 here, we're going to get plus. So plus times plus is minus. And then lastly, we can plug in a nice number up here. Let's just plug in 10. 10 times, so we'll have positive times 10 minus 1 is positive, 10 plus 1 is positive, they're all positive, so we're going to get positive. And then we need to decide which ones do we want to keep. So look here, it says bigger than 0, so which ones do we want? We want the positives this time. So this one's good, this one's good. And then to write that in interval notation, so for this part we can say we want to start at -1 up to 0 and open, open. Union over here, we would want to start at 1 and go up forever to infinity. And that would be our solution for that problem.